Hello and welcome everyone to today's session on network security and automated healing using NSO compliance service pack. My name is Giri Venugopal. I'm a software architect from Cisco customer experience team in the Americas region. I have about 12 years of experience in the software development domain, and over the last 4 years, I've been working on multiple projects involving NSO and its ecosystem to deliver network automation use cases.
Hi, I'm Eswaramoorthy Ramasamy, and I will be co-presenting this session with Giri. I'm a senior software engineer associated with Customer Experience Group, Cisco India. I have about 10 plus years of experience in the automation domain.
Thanks, Ishwar. So let's take a quick look at today's agenda. First, we'll be looking at the problem statement to see what is the exact problem that we are solving. And then we'll talk about the current trend of network security, which will be followed by some discussion on the real world or real-time threats and vulnerabilities. After that, we'll be talking about the fundamental pillars of network security. And then we will delve deep into the use case of our session, which is the automated healing using NSO, which will then be followed by a live demonstration. And towards the end, we also compiled a list of frequently asked questions to provide some food for thought and actually provide an in-person experience. Okay. Having said that, let's kick it off. Okay, starting with the problem statement. What exactly are we trying to solve here? So the main problem that we are trying to solve here is how can we mitigate unauthorized access of data? As we all know, data is wealth, data is intellectual property. Data is everything and it's distributed everywhere. Especially with the surge in the emerging technologies like IoT, artificial intelligence, machine learning, etc., data has been inevitable and it forms the common nexus that constitutes the knowledge base of all these platforms, right? So there's always a need for all these platforms to store and maintain a large volume of data for them to feed off of and then learn so that they can perform business critical services and activities, right? So each of these platforms, they come with their own inbuilt databases. They could be using any database technology, right? And they also come with their inbuilt scaling frameworks, and it becomes a challenge to maintain resources to hold all these data and databases in a single location, right? So think about maybe 10 years back where we had a single, a simple three-tier application with an app layer, the database, and a presentation layer, right? So it was just enough, or we could live with just a single database, and it was much simpler, right? But with the advent of all these new data mining platforms, it's become a challenge to store all the data and databases in a single place, right? So what is the alternative here? The cloud. The cloud has become the savior for us since it relieves us from having to maintain our local resources to store this much amount of data, right? So we could have a hosted environment, or go for the as a service model, have a private on-premise cloud or a public cloud, or a hybrid, or even multi-cloud. So there are a lot of cloud technologies, right? And all these cloud providers, they provide us with a ton of resources which is large enough to hold the data and databases that are used by all our platforms. But think about security. Is a security up to mark for all to ensure that all the data from the various platforms are protected? No, right? So the need for data protection is now more than ever. The cloud providers, however, do provide a certain level of baseline security, which controls, the entry and exit of traffic into the tenant model. But there is no control over each layer or each platform and the data that's maintained in each platform, right? So let me give you an example. So let's say, if I'm going to walk down through memory lane. So maybe like 7, 8 years ago, if I want to take a backup of my favorite music or, favorite pictures and migrate it from one computer to another computer, probably what I would have done is I would have bought like 5 to 6 pen drives or USB drives and then external hard disk and then, take a backup and then, move it to the other computer. And let's not forget there is another challenge, and you need to make sure that you carry these pen drives and make sure that you don't forget where you kept them, right? By this time, I would have definitely forgot where I've kept them, right? But if you ask the same question to me today, I would say, why do I just have to worry about it? I would just go for a quick cloud subscription, and I don't even have to carry anything around, and all my data is already migrated, from one system to the other. I don't have to even have local storage. I just buy a cloud subscription and everything is taken care of. That's how much cloud has simplified our lives here, right? But the security aspect is still a question mark. Even though there are new encryption techniques that are being adopted by the recent cloud providers, they are always neutralized by a new set of vulnerabilities. As again, we know, right? Innovation happens on both sides of the firewall, both inside and outside. So there are new breaches coming in today, hackers adopting new technologies, and the threats are also evolving. So the bottom line here is that data is always at risk, and the term 100% secure is always an understatement. All right. Okay. So what comes to mind when you think about cloud data security? I would say, oh, I've got a subscription, everything is maintained in the cloud. I don't care, it's all secure. But the reality is, the cloud is just another supercomputer that's just maintained on a remote location with a ton of resources. That's pretty much it. So the truth is, everything comes with a price. So does automation. Automation also comes with a price. In fact, it comes with a price that's little more than the actual price that you pay for automation, right? Because security is still not 100% foolproof. In fact, data security is becoming a liability as cloud providers are becoming more and more vulnerable because of the various cloud models. Having the hybrid models, data is split across multiple data centers, on-premise, public clouds, etc. Right? So data is kind of scattered in multiple locations, and often, we don't even have a trail of where all our data is being stored, right? And also with all these new technologies, security always has to make sure that it adds as an add-on layer for all these new technologies. So it has to constantly play catch up, and they have to keep up with these emerging technologies. Right? As I mentioned earlier, innovation happens on both sides of the firewall as threats are also evolving. So reiterating the fact that data is never 100% secure. Okay. So let's take a look at the network, right? Because it all starts with the network. So think of the network like the doors to your house, right? Either you as the owner of the house can walk in or somebody else could walk in, right? So we call the unauthorized entry as intrusions or breaches, right? And these breaches can come from multiple sources. They could be external, coming in from a hacker, or it could be from internal as well, where it could be purely unintentional, right? And in case of unauthorized access, hackers and network attackers mainly prey on human sentiments and weaknesses and try to exploit them as much as possible. A classic example would be, the first one that comes to mind is, the most popular, site, which is Craigslist.com. So, like 3, 4 years back, it used to be a very helpful site where you could, If you're moving, you could look for places to go rent or stay, or if you have some furniture or anything to buy, you could look into that and communicate with people. But off late, it's become a hacker's paradise, right? And not to mention the techniques like phishing, which have constantly evolved over the last 4 or 5 years as well, right? I mean, usually what they do is, they provide us, a secure link, which at least poses like a secure link, and they provide an attachment which lures the reader into opening them or clicking on the link where they ask in for username and password. And once the user falls a prey, they get the credentials and they are free to do whatever they want by entering into the network, right? So now the doors of your network are open, so anybody can come in and do whatever they want, right? And surprisingly, recent reports show that about 30% of phishing emails are opened by employees, and out of them, about 15% of the targets go on to click the link or open the attachment, right? So that's how personalized the phishing emails have become. So one method that we could adopt to mitigate the impact of these intrusions is to have a multi-level and a robust firewall framework with policies, and ensure that we can mitigate the external breaches. We are going to see them in detail in the upcoming slides. Okay, so now that we spoke about some of the reasons or the causes for breaches, we are going to look at vulnerabilities. And most of these are familiar. So the first on the list is about how do we manage non-compliant device configurations, right? This is one of the main sources of external vulnerabilities. So the network inventory can grow, can grow to a large number over time. And in most cases, the network engineering team, once the device becomes old and it becomes part of a legacy device, there is a tendency to, shift the focus away from them and focus on the recent devices, right? So in this case, the legacy devices, stay old, without having the latest features on the security updates, etc., right? So usually what needs to be done is, or at least the recommendation is, to have a golden config template for each device family and ensure that these templates are applied on a frequent basis on all the devices to ensure that all the new features, the latest security patches are applied on them, right? We could run compliance checks, and whichever device is non-compliant, we could run the golden config templates to ensure that they become compliant, right? Failure to do so is going to definitely make the device out of date, and it's going to make it vulnerable, exposing it, and the risk is going to increase there. The second in the list is human error. So we're all human, and to err is human. So there are a ton of mistakes a human or a network operator could make. It could be as simple as a small alphabetical or a typo. It could be in in terms of a bigger mistake where it could be more costly by a similar a typical example would be like having an incorrect ACL rule in the firewall, right? That could be much, I mean, the risks in that case are much more higher. And phishing, of late, it's been becoming popular, and the personalized emails have been the personal touch in these emails have been so much, so that you start to doubt your own sense of judgment. It could have something like, click on the below link to check the status of your recent Amazon order, right? Since most of us are using Amazon, I mean, you might be tempted to look into it without even thinking, right? So, that's how much personalized the phishing emails have become. And then we look at distributed denial of service is something that's been on for quite a long period of time. Again, there's just a distributed system of hosts that are attacking a specified target device, particularly its firewall, by sending or flooding traffic into the network, right? So since data is coming in from all directions, from a network of hosts, it brings down the system by using its sheer volume, right? So the firewall starts, checking starts inspecting each and every packet. Thereby, it's overwhelmed and stops functioning, and the device becomes unreachable. So there have been a lot of classic examples where DDoS attacks have been initiated by hackers, and organizations have been requested for a heavy ransom to free them from the DDoS attacks, right? And botnets, they are similar to DOS, but again, so these are they don't flood the target device. Rather, these are again a network of hosts that are running malware, and they are controlled by hackers. And once the hacker gains access to the network through through any of the above mentioned scenarios, he can inject the malware into the target host and do whatever he wants to get any data that he wants to, right? So cryptojacking is a recent trend that's been on since the inception of cryptocurrency. So it's basically a technique where you one can gain unauthorized access to a target host or a computer and its CPU and resources and start mining cryptocurrency. So once you gain access into the network, it's not only about mining cryptocurrency, you have access to all the data and you're free to pick whatever data you want to, right? And then comes the scripting vulnerabilities of SQL injection and cross-site scripting. So these are mainly, with respect to certain websites that are, very less, that are less secure, where you can inject any piece of script from your browser and reach the backend database and grab any data that you want from the backend database, right? It could be, personal data, secure data, whatever, credit cards or whatnot, right? And finally, the last one is the reversal of elevated access. This is something that pretty much most of us have seen. We might require some type of elevated admin access or root access to perform an operation or install software or download anything. We raise a ticket to the admin team, and we get the access. But once we are done with our tasks, the admin team has to make sure that the accesses are revoked, and you are restored with regular access. Failure to do so will again, will remain, can prove as a serious security threat, as there is someone who is not supposed to have elevated access, but does, and then he's free to do whatever he wants to. I mean, not in a bad manner. I mean, he could still perform a lot of loss of damage unintentionally, right? He could bring down some system, which he's not supposed to do so. So there's always a risk of bringing down some of the critical services. So these are some of the common threats and vulnerabilities, right? Okay, so now that we've been talking a lot about on the vulnerabilities and breaches, etc. Let's see what we can do to make our network tight and secure, right? So the first and foremost responsibility of the network engineering team is to make sure that their network is as secure as possible. As we mentioned earlier, have multiple firewall systems and policies, and ensure that the network is as robust as possible, so that we can minimize the possible or minimize the probability for potential data breaches, right? Again, there is no foolproof solution that can provide 100% guarantee against attacks, but all we could do is take action so that we could mitigate the effect of any potential threats. So here are some of the best practices and mitigation techniques. Using a multi-level firewall policy and ACL rules for different levels, right? For example, there could be multiple levels. We could have an app layer, we could have a database layer, other microservices that are running in your application. And it is recommended to have multiple levels of firewall and ACL policies for each level, right? So even if a potential breach or intrusion occurs in one level, let's say app level, the other levels are still secured, and the hacker cannot gain access into the other levels, right? So this way we can mitigate the impact of damage. The second one is a classic scenario where we have to ensure that we stay on top of applying all security patches and software updates, right? Typically, these applying patches and updates require a certain amount of network downtime, and the network engineers are they tend to postpone it for later. But we need to ensure that we find some time to ensure that we apply the latest security patches so that our devices can be more secure and the network can be more robust, right? And another mitigation technique is you could enforce setting strong password policies. I think this is pretty much followed everywhere. There is all IT organizations have strict password policies to make sure that their password contain a wide range of alphanumerical and special characters. Uh, you know, and it's also recommended to enforce policies that will mandate the user to change their passwords over a frequent period of time, let's say 6 months to a year, and keep changing their password so that the password doesn't remain a constant. And running compliance checks periodically, this is something that we saw earlier as well. We have to make sure that we make the legacy devices to be compliant and ensure that they get the latest security features and patches to prevent the risks of exposure. Multi-factor authentication is another recent trend that's been followed or widely adopted by a lot of companies. So it kind of increases the robustness of the network, even if the credentials might have been exposed without a secondary authentication factor, you cannot gain entry into into the organization's network, right? So multi-factor authentication is becoming a good way to make sure that you're secure that your network is secure. Regularly running penetration tests is this just another set of tests that are constantly being executed by the network admin and security team to ensure that all vulnerabilities are addressed. And even if there is some vulnerability that was overlooked, we make sure that we open up those and address those vulnerabilities, right? So all of these mitigation techniques would prove handy and would help us minimize the impact in case of any potential intrusion or a breach. Okay, so now let's talk about what are the fundamental pillars of a network security system, right? So there are three basic pillars, or three prerequisites that any network system, any network security system should implement, right? Protection, data, and reaction. Protection. So it is similar to prevention. Uh, Basically, prevention, we all know prevention is better than cure, right? So how do we prevent, potential breaches? You do it by protecting your networks as much as possible or as securely as possible. So it is a responsibility of the network engineering team to make sure that we follow the best practices and ensure that our network is robust. And when we come to detection, again, as we mentioned earlier, no network is 100% secure, right? So it is critical that in case of a breach or an intrusion, we identify it, as soon as possible. If a configuration changed, or if there was a drift in configuration, we have to make sure that these changes are detected early, and they could either be auto remediated by intelligent networks, or they should be notified to the network admin team as early as possible so that they could take remediatory actions and minimize the impact to a minimum. Reaction. So again, in case of a problem, it is critical that we detect the problem early and react quickly or respond quickly so that the remediation process kicks in and we return to safety as soon as possible, right? So this will help us reduce the network downtime and save the reputation of the organization as a whole. Okay, so now that we have seen about what are the pillars of network security, as well as we have talked about some of the vulnerabilities, etc. Right? So let's take a look at the current use case that we are going to demonstrate in today's session. So what are we exactly doing in today's session? So we are going to mimic, we are going to introduce a network change. We are going to assume that it's an unauthorized or an undesired network change. We are going to mimic a hacker who tries to tamper with the network configuration, right? So there will be a device which is being monitored for any unauthorized config changes or tampering. This device has already been pre-configured to generate SNMP traps for all these config changes, right? So this in turn would invoke a trap handler. The trap handler is nothing but a Python script that's been written, which will take certain remediatory action in case it receives an SNMP trap, right? So this trap handler is going to invoke our config compliance service pack that's been already deployed on the NSO, right? And our service pack would run a compliance check, and it would audit the network and check the compliance of the network with a golden config template that's been pre-deployed. So we do have a GCD or a golden config complete template that's pre-deployed, and we are going to run the compliance check against this template. So if we find that the devices are incompliant or non-compliant, NSO is going to take a remediatory action, and there are two flows here. So we're going to show two scenarios in the demo. So one which does an auto remediation or an auto heal to ensure that the configurations are immediately reverted back without the intervention of a human operator. In the second scenario, we will have the intervention of a human operator, and he will take a decision, based on whether or not to remediate or remediate the changes in the network. And finally, we will be generating a config diff report with showing some of the pre and post check differences of what was there before remediating the device and what is there after the device is remediated, right? Okay, so this is the high level flow of the use case that we are going to be demonstrating, the automated healing use case. So on the first place, you see the user who's triggering this network config change. So this will be an unauthorized user, and the change that he's going to be performing will be an undesired change. When he performs the change on the device generates an SNMP trap. Trap handler acts on the trap and calls NSO to run a compliance check, right? And when NSO runs a compliance check, if it finds any violations, it is going to take remediatory action to make the devices back again compliant. So these three stages, stages 2, 3, and 4, they fall under the detection phase. If you remember, if you correlate back to the pillars of network security, so these fall under the detection. So as soon as the SNMP trap handler detects that there's a config change, it's going to trigger NSO, and NSO would take remediatory action, and this will fall under the reaction phase, where it performs auto healing to ensure that the changes are reverted back. So with that, I would like to present Ishwar, and he's going to walk us through some of the components that are going to be used in our solution today, and he will be doing a live demonstration after that. Over to you, Ishwar.
One. Thank you, Giri, for explaining the importance of security and the threats as well as the attacks that are evolving today. In this session, we will be showcasing two use cases. The first use case primarily focuses on automated healing where no human intervention is required. And the second use case focuses on guided healing where if the changes if changes occurred and we do not know what to do, the system do not know what to do, so we get some guidance from the human touch point. These are the solution components involved in both the use case demos. NSO orchestrates the healing using Complaint Service Pack. Complaint Service Pack is developed by CX, and it is used for checking the violation and also to restore the configurations when required. SNMP trap D is used for listening to the traps and also to handle the traps by parsing the trap and understanding from which device the trap has occurred and also identifying what is the kind of trap. Is it a config change trap, or it's something else like an operational trap like link down or link up. We are using BPA as OSS BSS layer to showcase the guided healing. We are using 9396, which is a Nexus device for today's demo, and it's already configured for sending traps whenever there is a config change event. The first demo, as we already discussed, focuses on automated healing. So where absolutely no human intervention is required. So this is an animation showing you the sequence of events that's happening in the auto healing use case. So the user is trying to make a change on the network device. Once the change is successful, the device detects that immediately and then sends a trap to the SNMP manager. SNMP manager identifies from which device the trap is received and also what kind of trap it is. Since it's a config change trap, it's going to notify the NSO. NSO in turn runs a compliance check against that particular device. Basically, it's using a config compliance package in order to check if there are any violations. Based on the analysis, it finds that there is a violation, and hence it's going to trigger the next phase of phase, which is the restoration. During the restoration, it's going to pick up the right set of golden config templates and then push it to the device. Let's take a look at the live demo. There are three terminals in this screen. On the left, which is in the green color, is the terminal for Nexus 9396 device. On the right, which is in the orange color, is the terminal showing you the SNMP trap D logs. And the blue color terminal shows you the NSO system. So in this demo, we are going to impersonate a user who is trying to alter the ACL configs. So let me first show you what are all the ACLs that are existing in this particular device. I'm going to use show running config section access list. So we see that there is a ACL called as ACL business critical. So let me try removing it and then see what's happening. So I have removed it. Let me show you the running config once again. And you can see that the config is gone. On the right side, you might have noticed something is going on the trap, SNMP trap handler. What happened is once the config change is done, the device sent a trap to the SNMP trap handler, and trap handler in turn identified that some changes happened on that particular device, which is the Nexus 9396 device, and it notified the NSO. You might have also seen something happen on NSO side as well. So once the trap is received, SNMP trap D, which is the handler, processed the trap and then passed on the notifications to the NSO. NSO in turn ran the complaint check, and it found that there is a violation in terms of configurations. Hence, it initiated the next action, which is the restoration using a golden config template, and then it started restoring the configuration. Looks like the restoration is complete. So let's go on to the device and try to see if the restoration is complete. As you can see that this is the access list that I have removed, but it got automatically restored back by the NSO and the complaints pack, which is deployed on top of NSO. So this is how any kind of undesired config changes can be restored in seconds. This kind of automate healing will best fit for the cases where you want to kind of enforce some configuration, some standardized configurations. For example, you want to enforce a TACAX or a AAA configuration, or you want to enforce specific set of ACLs to the specific roles on roles of the network devices, or you want to enforce NTP configuration or a syslog configuration. Let's go back to the slide. Second demo focuses on guided healing. So there are cases where whenever there is a change, system is not able to manipulate or kind of identify whether the given change is valid or invalid. So in those cases, so we use humans assistants in order to kind of review the change, and they can kind of provide the inputs back to the system, that is either to kind of say that this is a valid config or invalid, and based on that NSO, I mean the system, meaning the NSO, can in turn kind of either restore or ignore the changes. So here is an animation to show you the sequence of events happening in the guided healing. This is almost similar to the previous automated healing, except the stage where NSO is trying to get the review inputs from the human touch points. So in our case, this is going to be either an operations team or a SOC team, security operations team. So user is trying to make a change onto the device. And once the change is applied, device detects the change and it's sending a SNMP trap to the SNMP manager. SNMP manager in turn notifies NSO. NSO triggers the complaint check. And based on the analysis, it found that there is some violation. But here, it is not able to kind of detect whether it's a valid change or invalid change. Most of the cases for which we know business critical or standardized configurations, we can make systems to easily understand whether it's a easily classify whether it's a desired change or a non-desired change. For anything outside of it, it's very difficult to kind of make the system to learn and then understand it. So we are actually using a BSS layer where the humans or the SOC operations team will get to know what are all the changes happening in the network, and then they can act upon it. So in this case, the NSO has forwarded the notification to the BSS system. The SOC team, which is the security operations team, will get a notification that there is some change on a device, and this is the exact change that got pushed into the device. Now, the security operations team can take a decision based on the config change that happened, whether they want to approve it or they want to reject it. So in this case, they have taken a decision to kind of reject this change. So this in turn is passed back to NSO that the SOC team has decided to reject the change. So NSO identifies the corresponding golden templates, and then it uses it for the restoration of the config on the particular device. Handing over to Giri for a live demo.
Thank you, Ishwar. As Ishwar mentioned, the main difference between the auto healing or the self healing and the guided healing is the element of the human operator. So, in the former case, the changes are related to business critical services, which normally do not require the approval of a human operator, and hence the remediation or rollback is pretty imminent. But in the latter case, in case of guided healing, the human element plays an important factor in deciding whether or not to remediate the changes and restore the configurations. So let's take a quick look at the high-level workflow that we are going to see in under the guided healing scenario. So we have this is the workflow, and I have color coded it in different colors. let me quickly give you a legend of all the colors, right? So all the green colored tasks mean that they are API tasks, which means that they invoke an API behind the scenes, and they are called as system tasks. Whereas all the blue colored icons, these are tasks where the human input or human intervention is required, right? So the workflow usually stops when it reaches a human task and waits, or remains in a pause state until the human operator kind of gives a go ahead whether to whether or not to go forward or not. So usually all these user tasks will be followed by a decision making gate here. You can see a gate here, and finally here it's kind of concluding the workflow, right? So all these tasks will have a human element, and we need to handle the different scenarios based on the input that the human operator might be providing. So in this case, we are going to use the admin logged in admin as our human operator, and he is going to provide the remediatory action that needs to be taken care of. And the orange task here just shows that it's an internal scripting task, which basically parses the parameters that have been obtained, that have been passed on to the workflow from the SNMP trap handler. If you remember, you should mention that we are passing, basic information like device name, and what config and what NSO is managing this particular device. So those are the inputs that are provided to this workflow, and we will be parsing those and getting those inputs from the request payload. Okay. So once the workflow starts here, we parse the inputs, and the first thing that we do in our workflow is make sure that, or check whether the device is already in sync with NSO, right? So we do a check sync to verify, and if the device is not in sync, we do call a sync from action to ensure that the device is synced with NSO, right? So once we ensure that the device has already been synced with NSO, we then invoke the compliance report through NSO, and there is a small time delay of about 5 seconds that's been added, which waits for the compliance report to be generated, right? So once NSO finishes the compliance check and the report is generated, we retrieve the compliance report and examine the output of the report to see if there are any violations or violating configurations, right? So here is a check. So we basically parse out the content from the report and see if there are any violating configurations. If there are no violating configurations, there's nothing left to do for us. So we are automatically ending the workflow. But if there are any compliance violations, in which in our demo we are going to have violations, in that case we do a pre-check activity here. Basically, we execute a show command. We just have a simple show running configuration command that's run on the device, and it will capture the current running configuration on the device. So we run that show command as a pre-check, and then we examine the report that's been compliance report that's been generated. We get the violating configuration changes from that report and present it to the admin user or the human user who needs to review the changes, right? So we get the non-compliant configs from the report and present it as a user task and provide it to the admin for review. So once the admin reviews it, he can choose one of two actions, right? Whether he can choose to remediate it and restore the original configuration, or he can just ignore it. If he doesn't want to remediate and wants to ignore it, we have a no flow here, which basically does nothing except other than executing the same post check, which is basically executing the same show running config command. And then we would generate a pre-post configuration diff report, and the diff report will again be shown to the admin user. So in case the user doesn't want to remediate, there won't be any changes, and it would be the same. There won't be any diff, and the user would conclude the workflow. But if the user wants to remediate it and restore the original configuration, then what we do is we get the non-compliant configurations, and we do perform a commit dry run and show the end user of a snapshot of what configuration is going to be pushed onto the device. So here we then create a user task and we show him a review of the dry run output that we got from NSO, right? and the user can look at the dry run, review that, and he can make changes. He can choose one of the actions, whether he wants to apply the changes or no. If he wants to apply the changes, we would again push those changes to the device using the GCT, the golden configuration template, and then followed by the execution of post checks, which will run the show running configuration command. So in this change, since we push some configuration, when we generate the pre-post diff report, we would see some new configurations being added as part of the post checks, right? So here we would be seeing valid difference because we are trying to push the configs back and restore the configuration, right? So in that case, we would be seeing significant configs, lines of configuration that are going to be pushed, right? And then the user can look at those configurations and he can conclude the workflow, right? So this is the overall end-to-end process that's followed in our guided healing scenario, right? So for this demonstration, we're going to go ahead with the demonstration. And for this demonstration, I'm going to be using BPA as the OSS BSS layer. BPA stands for Business Process Automation. It's a CX platform, CX network automation platform, right? So I'm going to be using it as the OSS BSS layer. Okay, so first let me go to share my terminal. And on the left side of my terminal, I'm logged into my Nexus 9396 switch, the same switch that Ishwar used for the auto healing demo. And on the right side, I am checking the SNMP trap handler log, right? So any changes in or any new traps generated would show up here on the right side, right? So let me first go and run the show command on the Nexus 9396 device and check the ACL section, right? So section access list. Okay, so as you saw earlier, this is the access list that we are going to remove and wait for remediatory actions to kick in, right? So go ahead into the config mode and remove this access list ACL dash business critical, right? So let me do that. I'm gonna go inside config mode. I'm gonna do a no and IP access list business critical. Okay, so now I removed the access list, and you can see right away the SNMP traps have been generated on my SNMP log. Right, it shows what device has been what device has been what device has triggered the log, and what is the action here. So it internally calls it makes an API call to BPA here, right? So it made an API request, and it's calling the compliance check to be executed on NSO. So I'm going to do a show command here to ensure that all the access list has been let me exit out of the config mode, then do a show running config. Okay, so there is no access list here. Everything has been removed and the traps have been generated. So now let me switch over to BPA. So here you see the BPA dashboard, right? So we have a workflow that's been triggered. So I'm going to go, all these are out of the box apps in BPA. I'm going to go inside the workflows app, and I see that there is one running instance that's been called. And I can see here, it's called the initiate compliance check workflow. And if I click on actions, I would see what are all the steps or what are all the tasks that have been completed. If you remember the slide that I shared, it had all these actions, right? Process input parameters, check sync, making sure the device is synced, triggering the compliance check, and then wait for the report generation, get the report generation, see if it has any violating configs, and if so, we are running the pre-checks, right? So now you can see the type of task here, right? So all these are service tasks, right? Most of them are service tasks. And the last one, or the most recent one that I see that's pending for the admin approval, is a user task. And I have an action assigned to the user. If you look at the right corner, I have an action assigned to me. So I can click on the form, and this basically shows what was the compliance or what was the violating configurations that were found in the compliance report. So I, as a network admin or a human operator, have the option to either remediate or not remediate, right? So this output that we are getting here is directly from NSO, and from the compliance report that was generated by NSO. So I am going to choose to remediate the action, right? So now the task is updated, and the next step after I remediate is going to generate. I mean, it's going to get the report object. It's going to perform a commit dry run and again show me or show the end user a dry run output, basically showing what configuration is going to be pushed to the device. When it's going to remediate it, right? So I'm going to go ahead and refresh the tasks. So I see here now that the remediation action has been performed, and now it's waiting on a second user task, which is the review dry run, right? So let me go ahead and see the form. It's basically the same set of configurations. You can see the ACLs that's been applied. The ACL dash BUS CRI and the ACL rules that are part of the ACL. So I, as an end user, look through these configs that are going to be pushed, and if I'm okay, if I'm satisfied with the configurations, I'm going to go ahead and approve the changes. Right, so I see the task is successfully updated. If I refresh, so the apply changes task has been performed. Now, if I go back to the flow, so it's going to apply the configurations to the device. It's going to run the post checks after that and generate the pre-post config diffs and create a user task for the user to review the pre and post diff, right? So let's go back and check BPA where it is. So if I'm okay, I see that the user task has been created for view pre-post diff. If I refresh my tasks, I see again the third user task has been generated, which is waiting for the end users, which is waiting for the approval from the human operator. View pre-post diff. I click on the action. So it just shows me the pre-post diffs for this particular command, the show running config. I could see here there are 7 new lines that have been added, 1 line that have been changed, right? I could open that and see that the timestamp changed, and if I click on load more, it's going to show me all the lines that have been added. This is the left. On the left you see the pre-check output, and on the right you see the post-check output. So on the right side I can see these 7 new lines that have been added onto the device. I see that the IP access list ACL-business critical has been re-added back or restored back onto the device, and I see all the rules have been pushed into the device. So I am satisfied with these changes. I'm going to go ahead and complete the workflow, and if I click on refresh, the workflow has reached the end state, right? And if I go back to my workflow instances, I see that it's complete, right? So now I'm going to go back and to my device and run the show running config command, and I see that the ACL has been restored back and all of the ACL rules have also been restored back. So this is how we can use the compliance service pack in tandem with an OSS PSS layer, so that you could have human interactions involved in the auto in the guided healing part, right? And with this, I would like to hand it back to Ishwar. Uh, uh, Ishwar, over to you. Thank you.
Thank you, Giri. Following are some of the questions that you might have got while watching this session. So we have put together some of the questions to answer the questions that you have so that it'll be easy for you to completely understand both types of healing that we have presented to you. The first question is that how we can trigger complaint check when the device is configured for multiple trap types. The SNMP trap handlers or the SNMP managers these days provide a sophisticated, fine-grained control in filtering the type of traps that are coming from the devices. Using that, we'll be able to filter only the config change traps and then trigger the complaint check only for them. Going on to the next question, when an undesired change on device triggers a trap, NSO pushes the config to make it compliant, which in turn triggers the config change traps. Would this get into a deadlock, right? So even in our demo, uh, the the same situation was kind of demonstrated. I'm not sure if you have noticed that. Uh, the complaints package first check if there are any violations. If only if there are violations, the templates are getting applied. And that in turn actually triggers the device to send a trap, one more tap, and the trap will be sent to the trap handler, and trap handler in turn will notify the NSO. In the second run, the violation check will give a status that there is no violation, and hence the flow will stop at that point. So in short, the answer is there is no deadlock. And some of you might have thought that, like, what if I add some configurations to the device directly, maybe introducing a new feature into the device. Maybe it's having like 10-15 lines of configurations. Uh, what happens to the complaint check, right? So the answer is, though the complaint check will be triggered for each trap and the templates will be applied only in case of violations, it's recommended to use the correlation feature of the SNMP managers or the trap handlers and reduce the ratio of the calls that are made to the complaints check to the number of traps that are coming inside. The last question that you might have is, hey, what if, what should I do to stop the auto healing? So I want to take a device for a maintenance, take down a device for maintenance, or I want to do an upgrade during the maintenance window, right? So I don't want to do or I don't want to run the complaint check periodically. I want to take the device out of the complaint check. So the simple solution is uh, prepare a list of devices and make the SNMP trap handler to kind of ignore those devices for the complaint check. So the SNMP trap handler can actually read the list present locally, or it can also talk to the external systems like change management system or an inventory system to kind of dynamically understand which devices it should actually ignore in starting the auto healing process or the guided healing process. Hope these questions would have answered or provided clarity that for the questions that you might have. In case if you have more questions or you want to know more, please feel free to drop an email to as-nso-service-packs@cisco.com. You can expect a response for your query within 24 hours. Hope this session was useful. In case if you have any suggestions or feedback, pick your mobile and either scan the QR code which is shown in the screen, or type in the URL http://cs.co/autoheal and then provide your valuable feedback. Just pausing the same screen for a few seconds so that you can scan the QR code. Thanks for watching.